Well, we want to welcome everyone to new user training, our first new user training of 2025. Typically, we try to offer new user training at least 3 to 4 times a year, and we're looking to start offering that more as well. My name is Charles Lively. I am a science engagement engineer here at NERSC. And I also have my colleague and counterpart, Lippy Gupta, as well. Lippy, did you want to introduce yourself?
Yeah, just as Charles said, I'm also a science engagement engineer. One of Charles and my sort of main tasks here at NERSC is to improve the new user experience. So we're always looking for feedback and just trying to make sure that your transition, if you're a new user, regardless of your experience with HPC, is as smooth as possible. It can be a learning curve, which is why we offer these trainings, but we want to try to make it a good experience. So, okay, I see lots of people are joining, but let's go ahead and get started with our Mentimeter activities. So yeah, go ahead and join, and let me progress this to our first question. So just to get a feel of who's in the room, if you want to uh, tell us a little bit about your scientific research. And while you're doing that, I'll also mention we're joined by a few other colleagues. Helen is here. Helen is a expert in our group with training activities and used to usually do run this training. So she has a lot of experience is gonna be helping us answer questions. And Rebecca is here. She's our boss, and she's also gonna be giving the first presentation. She may stick around a little bit, but those are also both really good resources if you have questions. In case Charles and I are presenting and we you can't, you know, you need some help or something. At least I think Helen will be around if you ask a question in the chat. She can try to monitor that and um, get us going. So, okay, I see a lot of, ooh, I see accelerator physics. I'm an accelerator physicist by training, so my brain immediately went to that. Ooh, a lot of people using CUDA, fusion energy, biology. Great. Okay, nice group, nice mix. Ocean physics modeling. That sounds awesome.
And we also have Justin Cook here,
Oh,
who is
Justin's
also a
here.
performance engineer at NERSC as well. So he'll be helping out with some of the questions, and he'll also be presenting tomorrow on programming and compilation environments at Perlmutter. So welcome, Justin.
Awesome. Okay, thank you everyone for sharing what kinds of stuff you're doing. So you can see a lot of people here, NERSC users are doing a variety of things. So we're kind of supporting people doing all kinds of different things while using our systems. Okay, let's go to the next question if I can. Yeah, where are you joining us from? So you can answer this in any way you want. You can tell us where you're from, where you are currently, where you go to school, where you work, whatever this question means to you, you can tell us. It is fun to find out where people are joining us from. Dirty Jersey, love it. Because then it tells us what time it is for you. Nice. Yeah, we do have a lot of Berkeley users. A lot of people at the lab tend to use at Berkeley lab tend to use NERSC, but we also have people all over the world, Mexico, Colorado, New York, oh, Switzerland. Ooh, welcome.
Quite a spread of users around the globe.
Nice. That's great. Cornell, woohoo, that's my alma mater. I guess it could be a different Cornell, but okay, awesome. Well, thank you for being here today, regardless of where you're joining us from. So now we just want to get a sense of in the room, how are people feeling about being here, about participating in high performance computing? Are you new? You might be new to NERSC, but not new to high performance computing. Um, do you think, do you are you, worried that HPC is super difficult to use and understand? We might try to dispel that a little bit. Like I said, there can be a learning curve, but you could do it. Everyone can do it. Um, yeah, and I know that the first question is a little hard to answer. Sometimes you might think you're new, but actually it's just because you're feeling like you haven't done enough, but you'd be surprised. You probably know more than you think. Great. Cool. Awesome. Yeah, that looks great. A lot of uh, different responses. Oh, you can see where people have been saying things. That's cool. Nice. And just for us to get a sense, we kind of, we're going to ask you these questions at the end too. So we just want to see, did this training help you feel kind of ready to go? Did it make you feel more nervous? What did this training do for you? Did it get you feeling like you can use the system? Uh, how did we do? For the record, you can feel excited and nervous at the same time. I basically feel excited and nervous every day.
I want to go ahead and get into the first presentation.
Yeah. Awesome. Thanks, everybody. Thank you for participating.
This is great.
And you'll see Mentimeter again in a bit. We're gonna have another activity later. Okay. Rebecca, did you want to run your own screen?
Yeah, sure. I can do that. Can you
Amazing.
hear me?
Yep.
Okay. Suddenly I was like, wait. Okay. Um, yeah, this is the right window. So first I just want to share with everyone, we've got this really nice Q&A doc here. And so you can just write your question in here and then we'll answer it. And so that link has been posted in the um, in the chat. So you can take a look there and maybe somebody can post it one more time just to be sure. But I am here to welcome you to NERSC. So I'm really excited to be here and get this opportunity to talk to you. So my name is Rebecca Hartman Baker. I lead the user engagement group. You may already know me because I send you an email every Monday. And now you get to see me in person. Okay, so we're going to talk about just kind of a welcome and overview. So here's our agenda. So first we're going to introduce NERSC and talk about some science at NERSC. And then we're going to talk about interacting with NERSC staff. So NERSC is an acronym and it stands for the National Energy Research Scientific Computing Center. We were established in 1974 as the first unclassified supercomputer center. Originally, it was really mostly for computations related to magnetically controlled plasma experiments. But since then, our mission has broadened. And so if you can do the math, you can know that in 2024, that was our 50th anniversary last year. So we've been around a while. But our mission today is to accelerate scientific discovery at the DOE Office of Science through high-performance computing and extreme data analysis. We are a national user facility, and we're located at Berkeley Lab in Berkeley, California, on the hill right next to UC Berkeley. So we are the Mission HPC Center for the DOE Office of Science. And so what that means is that we have allocations that are controlled by the Department of Energy. So 80% of the time available on our supercomputers goes through this ERCAP process, so you can get 100 or up to 10,000 hour sort of awards. Um, they are proposals that are submitted in August, September, October primarily, and those are chosen by DOE program managers. So NERSC doesn't actually decide who gets to use the machine for most of the allocations. It's DOE that decides that. And I should mention there are 6 primary offices in the Office of Science that use NERSC. And so these include bioenergy and environment, computing. Well, I guess these aren't the actual offices. These are just different fields that use NERSC computing resources. So, you name it, we pretty much do it if it's something that the Department of Energy is interested in. So I said 80% goes through the ERCAP process, 10% goes through the Oscar Leadership Computing Challenge, which is sometimes also called ALCC, so an acronym with an acronym in it. And Oscar stands for oh shoot, I knew I was going to bomb this, but it's the computing area within the Office of Science. And then the remaining 10% of the time allocated on the system goes to NERSC, where we decide. So we get to use some of that for our overhead, but also for critical strategic projects that we think are going to be important in the future. Okay, so let's talk about NERSC by the numbers. So we have users from all 50 states and 53 countries around the world. We have 10,000 users every year from about 800 different institutions. You can see we have kind of a breakdown here. We had about a third of our users are graduate students, so that is actually the plurality of our users is students, especially when you add in undergraduates. And then we've got a lot of postdocs, staff scientists, faculty, professional staff using our systems. Most of our users come from universities, about 60%. We've got a lot, though, from DOE labs and other government labs as well. And we have a few from industry and small businesses. NERSC is, we love science. And so we have about 2,500 refereed publications that reference NERSC every year. And on a given day, we'll have 1,000 different codes running. We'll have hundreds of users logging in every day. This is just kind of I'm not going to go through this, but our users produce really groundbreaking science, and we're really proud of that. And you can see, just all these different areas where people are producing really amazing scientific discoveries using NERSC. We're also really proud we have a bunch of Nobel Prize winning users. And these are kind of our older Nobel Prize winning users. We actually had a new one last year that isn't in that slide, so we should update that slide. Note to everyone. Okay, so now you kind of have an overview of what NERSC is and what we do and what our users do. And so now we're going to talk a little bit about the hardware at NERSC. So we get a new supercomputer every several years, 5 to 7 years. And so this is what we've got so far. So currently we're at Perlmutter. And that was our 9th system that we've procured. For that, we had Corey. And then before that, we had Edison, if anybody's a long-time user. And then coming hopefully next year, we'll have NERSC 10. We know what it's going to be like, but we haven't announced it yet. We haven't announced the name, but when we do, it'll be really exciting. It'll come hopefully in the middle of this year. We'll be able to announce NERSC 10 and what it's going to look like. Now, something that we've been doing over these past few years is, really increasingly energy efficient architectures. So that's something that's really important now as we get up into megawatts of power that we're using. So you can figure 1 megawatt of power is about $1 million. 1 megawatt year is about $1 million. So that's pretty expensive, and so we need to be able to keep our bills as low as we possibly can, especially especially for energy efficiency as well, and the environment. We care a lot about that. So we have Perlmutter. Now, Perlmutter is named after a guy named Saul Perlmutter, and there's a picture of him. He shared the 2011 Nobel Prize in Physics for the discovery of the accelerating expansion of the universe. And the way he did it was he actually combined experimental results and large-scale simulations to come to this conclusion. And so he is still around. He still works at Berkeley Lab, and we asked him, "Hey, can we name this computer after you?" And he said, "Yes, but there's one requirement." So he felt like his name, Perlmutter, was too long. So he asked us to be able to let people be able to log in using his first name, Saul, which is only 4 letters rather than 11. So you can also log in, you can either log in perlmutter.nersc.gov or saul.nersc.gov, depending on your preference. Okay, so let's talk about what's in Perlmutter. So Perlmutter has 2 types of blades in it, and these blades actually stack kind of upright vertically into server racks. And so let's talk a little bit about these 2 different types of blades. So we have one type of blade that has a GPU node on it, and what that means is it has a CPU. All of them have a CPU, but it also has 4 GPUs on the node. And then we have other ones where each node has 2 CPUs and no GPUs. So those are the 2 different types that are in the system, in the machine. And so then we're going to see a little bit more detail about this. So if you look inside of the machine, like I said, each of these is a blade, and this is our cooling system. And actually, when the machine is operating, if you go here and you touch the red one, it's hot, and if you touch the blue one there, it's cold. So that's kind of an interesting fact that it's using a liquid cooling system in order to cool the machine. That's more efficient than using fans. Okay, then I just want to say, really, that's not all about the system. It's really a sum of many parts. So in addition to just these blades that we've talked about, we have an interconnect called Slingshot. And that is kind of a proprietary HPE sort of a interconnect. And then we also have an all-flash scratch file system that is connected to the machine. It's very fast and has a whole lot of storage in it. So if we keep going here, the details are we have actually 3,072 CPU-only nodes, and each of them has 2 AMD Milan CPUs and a total of 1,536 terabytes of CPU memory. And then we also have our GPU nodes. So we have 1,792 of those. And they have 1 AMD Milan CPU and 4 NVIDIA A100 GPUs. And then in aggregate here, we have 448 terabytes of CPU memory and 320 terabytes of GPU memory. Okay, so then in addition, so we kind of know about what the machine is like. The machine is connected to ESNet, which is basically the ISP for the Department of Energy. But we are connected with a 1.6 terabit connection, or yes, that is right. And so we are actually the first ones to connect to ESNet at that level. And then finally, we have a bunch of other stuff at NERSC. So we've got our tape archive, HPSS. We've got a common file system. It's a very large file system that's also connected to Perlmutter. And we've got our home file system, which is pretty small, but it's just used for just storing not very much stuff in it. And then we've got data transfer nodes. We've got gateways, and we've got Spin, which is kind of our edge service. It's where you can have stuff like data sharing portals and other really interesting connections to NERSC. Okay, so do we have any questions so far that I need to address, or Anybody? Okay, I'm going to keep going then. Okay, oh, I think we already saw that. So the system is a sum of all of these different parts. So next we're going to talk about interacting with NERSC staff. So first we're going to talk about my group, the user engagement group, and then we're going to talk about consulting and account support. So this is my group. So that's me, and then this is the rest of us. And so you've met Lippy, you've met Charles, Helen, um, and I guess maybe some other folks around. I'm not sure, but this is our group, and I'm going to talk about kind of the things that we do. So, okay, so we. Oh, okay. I don't know why that didn't get updated. We are a community. Okay, sorry. Let me back up. The NERSC user group. We have a user group that I hope that you all will join. It is our community of our NERSC users. It's a great source for us for advice and feedback. We do listen to what our users have to say. We have monthly teleconferences, which we call that our community calls. And so there's going to be one next week. We have a Slack channel that we encourage you to join. It's not an official source of NERSC support, but it's a great way to connect with your colleagues and to talk to each other about things that are happening. And then I thought I updated this, but we had an annual meeting last year for our 50th anniversary. We will have another annual meeting this year, but it has not been scheduled yet, but it's generally scheduled either in the summer or the fall. Okay, so I'm going to talk about our user training. So we provide a robust training program for users of all skill levels, interests, and all different types of users. So our trainings are recorded and professionally captioned, and we post them to our YouTube channel. So this training will be posted to our YouTube channel. And then we also post the slides on our training event webpage. You can see more information on our upcoming and past events at this URL. We also have a collection of categorized training materials, and we have a training events archive. So next, we're going to talk about consulting and account support. So we have a big team. This is beyond just the people in my group. You can see there's a lot more folks here. And then we invite you, if you're running into issues, to submit a help ticket. So if you just point your browser to help.nersc.gov, then you can submit a ticket. So this is what it looks like when you get onto help.nersc.gov. There's a help portal. There's a pointer to our documentation. There's an option to open a ticket or open a request. We have some request forms for things like increasing your disk quota of like your Scratch disk quota or whatever. Anyway, the help portal is a great place to get some help, open a ticket, or make a request. Oh, I didn't realize that it was going to do that. Yes, so you open a ticket with this thing right in the middle here. Open a ticket. Okay, so when you do open a ticket, we would really appreciate it if you would help us to help you. So if you just send in a ticket that says my job died, well, that's not terribly helpful. What we would like to know, like, what is the actual problem? What machine were you running on? Which node, which file path was your input file, all those sorts of things. When did it happen? What was your programming environment? Like what modules were loaded? Did you do anything to try to fix the problem or work around it? And then kind of how can we reproduce the problem to try to make sure that we understand what's happening? So we do actually have a document here on how to file a good ticket. And so it's great if you could look at that. I mean, if you just say my job died, well, we can ask you all these questions, but it'd be just faster for everyone if you just kind of give us as much information as you can from the get-go. Okay, so now we're going to talk about NERSC consulting expectations. So our first response to you will be within 4 business hours. So our business hours are Monday through Friday from 8 a.m. to 5 p.m. except holidays. And then if you send in a ticket overnight, we'll answer it starting at 8 a.m. If you send it in on a weekend, we're going to answer you on Monday morning. So within 4 business hours, we will at least respond to you. We're going to help you to resolve your problem and keep you apprised of the progress. We're going to try to accommodate your needs that don't fit within our operating structure. Sometimes people have some needs that require some exceptions to our policies or some rules. And so we try to accommodate when we can. And we always welcome your feedback and your constructive criticism. Okay, so now I'm going to talk about user appointments. So in 2018, we started offering office hours, and we still do those sometimes. But basically, the idea was it was an open Zoom meeting where you can join to get help with a particular topic that we think users really need some help with. So for example, when we changed over from just passwords only to using multi-factor authentication, we had office hours on MFA. The problem that we've found with office hours is that we'll have long periods where we're just sitting there alone with no participants, and then suddenly 10 people all jump on at the same time. So I don't know if any of you are professors and you have office hours, you may find a similar pattern for you. So instead, what we decided was, hey, what about appointments? Appointments are more efficient use of everyone's time. So now we do offer 30-minute appointments on a variety of topics. So GPU basics, optimization, file systems, using GPUs in Python. NERSC 101, I think, is the most popular one. And so you can schedule an appointment with us on this system. It's called Acuity Scheduling. If you ever go get your hair done or something like that, your hairdresser may use this appointment system. So you may be familiar with it, or maybe not. Anyway, so you can always schedule an appointment with us. We really like that, and we really like to help. All right, any questions that I should address right now? Anybody have a question?
We're good here in Google Doc.
Okay, good. All right, well, then I shall move on to just my final things. Thank you, and welcome to NERSC. We're really glad that you're here.